In this opening module, we will be covering the three fundamental building blocks of a brake system, specifically friction, hydraulics, and mechanical advantage. To understand how an automotive brake system works, there are a few fundamental concepts we need to review: levers, hydraulics, and friction. Remember when you were young and rode the seesaw? You may have noticed how moving the board affected how it operated. Two things happen. The longer the end is from the fulcrum point, the greater the force applied to the opposite end, and the greater the travel of the short side. If we position the board so twice as much is beyond the fulcrum, we can support an object on the short side with half the weight. This will all make sense when we look at how the brake pedal operates. Hydraulics is a means of transmitting forces using non-compressible fluids such as oil. Nearly all the force transmitted, as well as the displacement of fluid, is accomplished. In our example, because both cylinders are the same size, whatever force we apply to the left side is transferred to the right. Additionally, both plungers will move the same distance. Since hydraulics transmit pressure equally and uniformly, the piping connecting each component can be of any length and shape, since the same amount of force generated at the origin arrives at the destination. Like we saw using the seesaw, hydraulics can easily multiply forces. You will better understand this concept when we discuss master cylinders, calipers, and wheel cylinders. Braking systems rely on the specific concept of friction to slow or stop a moving car. Friction is the measure of how hard it is to slide one object over another. The term used to describe the ratio of force applied to the object's weight is called the coefficient of friction. Different materials have different coefficients, and that is important to remember when discussing brakes. The Greek letter mu is used as the symbol for coefficient of friction. So if we have two objects, one weighing 4 times the other, if mu is the same for both, it will take 4 times the force to move the heavier object. Notice how mu affects how much force is needed to move an object. If we reduce it by 10 times, we also reduce the amount of force needed to move the object by 10. Here are some common values of mu for various items. Note that 0.4 represents an average value for friction material against its normal rubbing mate. An automotive brake system has two functions. It must be able to slow or stop the vehicle, and it must be able to hold the vehicle stationary when placed on an incline. It does this by using service brakes and parking brakes. Now we can apply what we reviewed from the fundamental overview to the entire brake system. Friction, hydraulics, and mechanical advantage are all used within any braking system.